Good morning, everybody. Today we are continuing with word problems. We only have 2 questions today. They're definitely a little bit more on the challenging side, but they were Regents questions, so I think it's really good for you guys to see these. We're still talking about area, so just remember, and you could see this like rectangular garden, so I'm just going to make sure everybody remembers that area equals your length times your width, okay? So it says a rectangular garden, so that's in the center there, is measuring 10 by 22. Okay, and they're saying that they're going to put a walkway around the entire width, and that width is measuring X meters. So you see here, this is X meters. So all the way around, the width of that walkway is X meters. Okay, and then let me try to show a different color. Understand this side of your garden is 22 meters long, and this side of your garden is 10 meters. Okay, so the question says together the walkway and the garden have an area of 640 square meters. So understand this, that your garden, okay, this inside the area of the garden in here, this area is 22 times 10, which is 220 square meters. And then the entire thing, so let me go new, try to go new color. This entire thing, I'm going to put it in like this. Here, and here, and here. Okay, the bigger rectangle. The bigger rectangle has an area of 640 square meters. So they want you to write an equation that could be used to find X, the width of the walkway. Okay, so remember, we need to figure out the length. Here's what we're really trying to find. If we know this entire rectangle has an area of 640, what's the length and the width of that bigger rectangle? Okay, we need here the length and here the width, right? From literally here all the way to here. And the width here all the way down to here. Okay, so literally I almost want, you guys can speculate, you could start thinking about it. People will say 22, so I want you to think about the 22 up top. From here to here is 22. The length here to here is 22. Does everybody agree? You see that? That smaller inside rectangle measures 22 meters. But there's still this piece. So let me get a new color. This piece and this piece. What do those pieces represent? Well, look down. What does that represent right here? X. And this piece right here, look all the way down. What does that represent? Also X. So how can I write that length of that top side? I have X, 22, and X. And what would I do to all of those side lengths? Add them. What's X plus 22 plus X? How can I write that? 2X plus 22. There's your length. Okay, X plus X is 2X. Remember we said the other day, X plus X equals 2X. X times X equals X squared. Okay, so now let's talk about the other side. Let's talk about this side. Does everybody agree from this piece here to this piece here is 10 meters? But what's missing? We're missing this piece and this piece. Okay, so what represents those two pieces? The same as the other one. You're missing this X. This is an X. And the length of this walkway is also X, right? That length, because remember, we want this entire side. We really only knew 10 meters of it. The other two pieces are represented by X. So we have an X plus a 10 plus an X. What's that going to be represented by? 2X plus 10. So there is your length and your width. So remember, how do you find your area? Length times width. So if I took 2x plus 10 times 2x plus 22, my length times my width, what does that have to equal? My area of 640 square meters, okay? Let that sink in for a second. It's not easy. Okay, does everybody see how we came up with that? Literally, picture almost like a little person walking the walkway. This piece is X. This piece all the way to here was 22. This piece was another X, so that's 2X plus 22. Okay, and you could do the same thing going down the other side. Now they want you to determine and state the width of the walkway. Well, what's the width of the walkway? Okay, that's X. The width of the walkway is X. So all they want you to do is solve for X. Okay, so now you're going to take this equation. I'm going to take 2x plus 10 times 2x plus 22 equals 640, and we're going to solve. Well, what would be that first step? Hopefully you're saying you should double distribute. You could set up a box method. I haven't done a box method in a while, so I'm going to just go off to the side, and I'm going to show a box with, and you could double distribute if you prefer. Okay, I'm going to show a box with 2x plus 10 and 2x plus 22. 2x times 2x, not add, multiply, is 4x squared. This is 20x. This is 44x. And this is 220. So when I come back here and I want to rewrite this, remember the only thing I really should do is combine my like terms. I get 4x squared plus 64x plus 220 equals 640. And always remember, you're looking at a quadratic equation. How do I know that? My highest exponent is 2. That immediately makes it quadratic. So that means I have to set it equal to 0. So subtract the 640 over to the other side. Okay, and when you do that, this is gone, and I have 4x squared plus 64x. 220 minus 640 is minus 420, and that equals 0. And a lot of you, I know, will immediately start to say, oh, we're going to multiply 4 times negative 420. But what should you always look for first? Look for a GCF. And look at the smallest number that you see there. It's 4. Does 4 go into 64? Yes. Does 4 go into 420? Yes. Divide every term. I'm going to go new color. That's your GCF. Now, it's funny. I'm not pulling it off in front. When you have an equation, you don't have to pull the GCF in front. If you could divide every single term by that GCF, get rid of it. Divide it out. I even divide it by the 0 to now make an equivalent equation of x squared plus 16x minus 105 equals 0. okay? And now you're looking at a basic trinomial. So I know it's kind of a big number. You have the number negative 105. Ask yourself what multiplies to negative 105 and adds to 16. And your numbers are positive 21 and negative 5. Okay, if you divide 5 into 105, you get 21. That's it. So you need 21 to be positive because it's a positive 16. So the bigger number has to be positive. X plus 21, x minus 5 equals 0. Set up our little t. X plus 21, x minus 5. So here I'll subtract the 21. Here I'm going to add my 5. Okay. Can x equal negative 21 and x equal 5? What are we talking about here? The width of a walkway. Can the width of a walkway be negative? No. Can't be negative. Okay, so your answer is x equals 5. Okay, that is your width of your walkway. Not easy. That was a long one. That was a big 6-pointer, just so you know. It's not like that would have been, that was a big 6-point question. Okay, so now let's try the next one. This was another tough 6-pointer on the Regents. New Clarendon Park, right? So New Clarendon Park is undergoing renovations to its garden. Another garden question. One garden that was originally a square, this is a key word, originally a square, is adjusted so that one side is doubled in length while the other side is decreased by 3 meters. The new rectangular garden will have an area that's 25% more than the original. 25% more. Okay, so that's a tough thing. So I'm going to just write a couple of things. I want you to write an equation to use to be determine the length of the side of the original square garden. So I'm going to just make a few notes. Like first, if we talk about the original, okay, in the original, what do we know about the original? It was a square. Okay, what do we know about a square? A square, they all have the exact same side length. This and this and this and this are equivalent. So if we don't know what that side length is, what can we name that side? X. We know every single side of the original was just X. It's an unknown. We have no idea what it is. But in the new one, we now know it's rectangular. Okay? So I'm going to make now a rectangular garden. Okay, not the greatest rectangle, but good enough, right? Okay, so now in this rectangular garden, here's what happens. One side is doubled in length. So how would I take that original and double? Double means multiply by 2. So instead of x, it's going to become 2x. There's your new one. New length is doubled. The other side is decreased by 3. So your other side is decreased by 3. You're going to take x minus 3. Okay, here's the hardest part. Your area. Now, we didn't talk about the area for your original. So can anybody figure out what the area would be for the original? How do we find area? Well, in a square, it's side squared, or it doesn't matter, length times width. X times x, x squared. So what would be the area here? Now, little tough. Most kids will be like, oh, it's 2x times x minus 3, which is true. But what they told us, they gave us a really important piece of information. It says that the new rectangular garden will have an area that's 25% more than. 25% more than would be not just 0.25, 1.25. Okay? The original area, which is the 1, plus another 25%. So take that and multiply it by your x squared. 1.25x squared. That was kind of tough. Now they want you to write an equation that could be used to determine the length of the original side. Well, we now know, using the new dimensions, that 2x times x minus 3 has to equal 1.25 x squared. Okay? And now we're going to take that equation and we're going to solve. So I'm going to take 2x times x minus 3 equals 1.25x squared. I am going to distribute to get 2x squared minus 6x equals 1.25x squared. Okay, so this one's interesting. I have two different x squareds. I want it to always equal 0, and I want my x squared to be positive, so I'd have to subtract the 1.25x squared to the other x squared term, 2x squared. I'm going to cross that out, and I wind up with 0.75x squared minus 6x equals 0. Okay, so this happened to be tough. When you look at this question, they actually, what do I always tell you to look for first? Look for a GCF. Do they have anything in common? I mean, to be honest with you, if I took they actually have a GCF of x, but I would take the smaller number, that 0.75. Now, it doesn't matter. You could do one or two things. If you don't see that 0.75 goes into 6, and you want to just say, oh, they both have an x in common, this is okay. Okay? Let's say we just do that, okay? Because I think it would be very hard to say, oh, 0.75 goes into 6. So let's just take out an x. If I took out an x, what am I really doing? I'm dividing this term and this term by x. Well, what would I have left? 0.75x minus 6. And then I'm done. Really, I have my two factors. I could take x and set it equal to 0, and then I could take 0.75 or 0.75x minus 6 equals 0. I could add 6. So 0.75x equals 6. And when I divide both sides by 0.75, x equals 8. Now, I guess I shouldn't outline it. Can both of these be my answers for the length of or what was it? The length and width of that original square, the side of a square. Could the side of the square be 0? No, that makes no sense. This one has to be a reject. Okay? But what could the length be and width be? 8. That means that this all right here, go back to the original, all of these sides had to have been 8. Okay? And they wanted you to determine the area of the new rectangle. So the funny thing is, kids stop there. Oh, 8. But that wasn't really what they wanted. They want the area of this guy. Okay, so I could do this. 2 times 8. I now know that side is 16. And 8 minus 3, I now know that side is 5. So technically my area, I forgot my equal sign, is 16 times 5. So my area is 80. I could have also taken that 1.25, plugged in my 8 squared, and done 1.25 times 64. And if you do that, you get 80. So either way, your answer is 80. Ooh, that's tough. Lots of work. Okay, I'm going to give you guys a couple of practice questions, but let me say this to you. If this is like way over your head, I get it. These are advanced, very challenging questions. So don't stress it if it's a struggle for you. This is almost like a challenge day. I'm going to give you a practice sheet, and then we're going to be wrapping up quadratic equations, which is kind of exciting. Okay.